of 2t times cosine of 3t. Hey guys, I'm going to be using this video as a representation of how to find the integral of this function using by parts. Integration by parts. Now, in this process, remind you that the formulas are out there. You can search them up. But integral of u dv equals the uv function, multiplying them together, minus the integral of v du. So what we need to do in these types of problems is figure out which of these functions are we going to call the u function and which are we going to call the dv function. The use of that function, the way to determine that is with something that we call, there are others that are out there, but this is the one that I feel the most solid on for presenting to you guys. And it's the acronym LIPIT, which stands for, first of all, look for logarithms, certainly like natural logarithms. Secondly, we look for inverse trig functions. Third, we look for polynomials. Fourth, we look for exponentials. And then last of all, if everything is all trig, essentially, then we have a relationship with trig that we could use. But if you identify, based upon this order, which of these two functions that's in here you're going to call the u in our by parts formula, things will go pretty smoothly. Here we have 2t cosine 3t, and I kind of want to acknowledge that we should just move the 2 out front. But maybe because of the nature or structure of what's going on here, don't do that. You can, I just think you're adding complexity to the problem. So I'm going to leave it in there. We'll just see what happens. Mainly because I think the 2 is going to cause like a doubling effect that will lead to further complications. So I'm going to set up on the side, work on the side. I'm going to say u equals 2t. And if you do a u sub, you have to also do a du sub. So the differential of u would be equal to 2 differential t, 2 dt. That means that this is our u, and the rest of this, including the dt, is our dv. So I'm going to identify that as dv equals cosine of 3t. Then our v has to be the, oh, I forgot the dt part of it, but I'm running out of room. So there's a dt on the end here. I'll kind of like smush it up on the side. That means that our v function has to be the antiderivative of cosine of 3 dt. And I maybe want to like pause for a minute and acknowledge that if I'm going to find the antiderivative of cosine of 3 dt, you know, integral, etc., then I'm going to have to do a u substitution inside the by parts process, because I have to focus on just this integral in this moment and decide, okay, what is it about this section that needs the love, that needs the work? So I'm going to, let's see here, I'm going to call the, I shouldn't use u. You can use the u letter multiple times, but it's going to start getting muddled. I'm going to use box. Let's say we're going to do a box substitution. This is totally a, a my thing. This is not a typical thing. Like to say something is box. All right, so then the derivative, the differential box would be 3 dt. So in other words, we're going to solve for dt, and we're going to put that back into here, and then we're going to look at our integral, right? So we have the integral of cosine box, and then if I divide both sides by 3, that means I'm going to divide d box by 3. Or really just everything is divided by 3. It's a constant. And because it's a constant, I can separate it out. We can pull this forward to the front. This is our v function for the whole thing. So this is going to become 1/3 the integral of the cosine box d box. Now because of that, our knowledge should let us know, like, what's the antiderivative of cosine? It's positive sine. So this becomes 1/3 sine of the box, and if you want you can put the plus c, but let's just save plus c for the final answer. There are reasons to think about it throughout the problem, but in these types of problems, no. Then that means 3t is going to go back where the box is, because that's a put the information back in step. 1/3 sine of 3t. Maybe you can see that pattern happen the more often you see these, to like not have to do this u substitution here. But until you are correct in moving from the integral cosine 3t to the antiderivative 1/3 sine 3t, then you got to show the middle steps. Now, everything is all set up. We've done our work on the side, so now it's time to actually go forward and calculate. We're going to use our formula here, uv minus integral v du. So u, say this is an equal sign here, that means that u is 2t. V, we just found it, v is 1/3 sine of 3t. So 1/3 sine of 3t. That's the first part. That's the whole like process of integration by parts. Now we're going to subtract the integral, and this time it's v du. So v is this 1/3 sine 3t. And use parentheses in most cases. dt, like parentheses around all of this, right? All of that is the integrand of the integral. Okay, so here we have it. We have the expression uv minus the integral v du, and then I put the constant part on the inside. Okay, so combining like terms, like pushing constants together through multiplication, gives us 2t over 3 sine of 3t. The 2, which is kind of why I left it in, but if I had taken 2 out in the beginning, that means that all of these would be doubled anyway. But it's kind of like a distribution. When you properly distribute, you're getting the right answer, but sometimes we can make mistakes with distributions. Just leave the 2 inside the integral for these for now until you see some patterns develop and you can use those patterns. Here we have 2 and 1/3. So I'm going to take the 2 times 1/3 as a constant and bring it outside of the integral. 2 over 3 times the integral of sine of 3t dt. So we already kind of answered this question with cosine. We should be able to see somewhat of what's going to happen here. The 3t is going to become the substitution, the thing we're going to sub out. We have a substitution u value and a du, or I guess we used box in the last case. But what ends up happening is there's a 1/3 that pops out of the problem. So this section right here, I would recommend that you work it through, but I'm going to jump to it, will be 1/3 times negative cosine of 3t. That's the entire integral. Bringing it all into light with everything else that's there, we have equals 2t over 3 sine of 3t minus 2/3 times 1/3, so that would be 2/9, 2 over 9. The negative and the negative, that is a multiplication process, so we're going to add those together. And then last of all, cosine of 3t. I should keep the parentheses, don't drop them. Plus c finishes the problem. There you have it, the antiderivative of 2t cosine of 3t. And if you take the derivative of this, if you take the derivative of our answer, that's kind of the proof of this is left to the reader sort of a thing. You will see that it all collapses and combines back into the original function. Thanks for watching this video. Stick around for some more. See you in the next video.